Hi, welcome. This is videos on simplifying radicals at the level 4 or highly proficient level. And we've got what we would call here the cube root. So it says simplify the radical, the cube root of negative 16 n to the 7th power. So what I think makes this a little bit trickier than, let's say, the last one, it was a square root. So we just have to pay attention to the fact that now we have some index other than 2. So we got to pay attention to that 3. And we'll get to that here in just a second. So first I'm going to take 16, I'm going to break it down into its prime factors. So I'm going to go off to the side here, I'm going to write 16 is equal to, let's just, I'm going to go to the smallest prime factor, which is 2. I'm going to say 16 goes into, or 2 goes into 16 8 times. And then 2 goes into 8 4 times. And 2 goes into 4 2 times, and 2 is prime. So I have 1, 2, 3, 4 2s. 16 is equal to 2 times 2 times 2 times 2. That's 1, 2, 3, 4 times. Or you can say 2 to the 4th power. And we'll use this. They're the same. And then I'm going to end of the 7th. So what I'm going to do here is I'm going to break this down. I want to address the negative, because up here, when we had a negative under the square root, in the real numbers, there's no real number that if I multiply it by itself 2 times, I'd get a negative number. So we have to use the imaginary number I. But with the cube root, let's just use this as an example. If I have the cube root of negative 8, I'm asking myself what number multiplied by itself 3 times is negative 8. And here the answer is negative 2. Because if I take a negative 2 times itself 3 times, negative 2 times negative 2 times negative 2, and negative 2 times a negative 2 is a positive 4. Times that other negative 2, and then 4 times negative 2 is negative 8. So if you have an odd number of negatives, then you can get a negative result, which is why if you have an odd index and a negative under, that's not going to give you the imaginary number I. It's just going to be negative. So we know this negative is going to come out from under the radical as negative. So I'm going to say, we'll just break it down here. Let's say the cube root of negative 1 times the cube root of 2 times 2 times 2 times 2. And then I'm going to say times the cube root of n multiplied by itself 7 times. So n 1, 2, 3, 4, 5, 6, 7. Now, first off, I know that the cube root of negative 1 is just still negative 1, because negative 1 times negative 1 times negative 1 is still negative 1. And then here, because you've got the cube root of 2 times 2 times 2 times 2, instead of looking for pairs like we were up here, I had 2 2s came out as a 2. Here, I'm looking for 3. So 2 times 2 times 2, there's 3 2s there. That's going to come out as a 2. So times 2. This 2 here is going to stay under the radical. And here I'm looking for groups of 3 n's. There's one group of n's, of 3 n's. There's another group of 3 n's. Each of those is going to come out just as an n, and this one is going to stay. So I've got times n, or you could do that mentally, just say that's n squared. But I'm going to multiply all these together. And then I've got what stayed under the radical? This 2, so that's the cube root of 2. And then I've got just one n, so that's the cube root of n. Now this is all kind of messy. I'm just going to clean it up. I'm going to take negative 1 times 2 and give me negative 2. N times n is n squared. And then the cube root of 2 times the cube root of n is now equal to the cube root of 2n. And that is my answer. So one thing I would say, be careful about, is make sure that you're drawing a distinction between what is your index and what is an exponent of another number. So this 2 is an exponent of this n here. That's n squared. But this 3 is the cube root of 2n. So there you have it.